Hello and welcome to BrainLinker. Myself Vishnu Radhanpura. In the previous video, I had discussed about compiling and running fast Java program. In this video, we are going to explore data types. So, what comes in your mind when you heard word data type? Probably you are guessing type of data. Yes, it is. Data types are, as name suggests, type of data. But first of all, question arrives, why data types are needed? Just imagine life without data types. Let's take a story and understand this. There are two friends, Vishnu and Shridan, talking to each other. Vishnu asks for mobile number of his friend Shridan, and Shridan gives number 123456.0. Then Vishnu dials that number and ended up getting reply, please check the number. This leaves Vishnu in inconsistent state as mobile number is 10-digit whole number which doesn't contain fractional part, so chances of mistakes are drastically increases without data type. Thankfully, this is not the case with Java. There are two types of data type. First is primitive data type and other is non-primitive data type. In this video, I am only going to discuss about primitive data type. Then primitive data type. Type is a classification of data which tells the compiler or interpreter how the programmer intends to use the data. Every variable has data type. Expressions also return answer in some particular data type. Variables as of now you can think as name of particular memory area. Data type tells what kind of data a variable must contain. In addition to kind of data, it also specifies which operations may be performed on it. Now let us see classification of primitive data type. Primitive data types are divided into four parts. First is character, second one is integer, third one is floating point, and fourth is boolean. Again, integers are divided into four parts. First is byte, second one is short, third one is integer, and fourth is long. Floating points are divided into two parts. First is float and second one is double. Now let's jump into integer first. Integers are used to represent numerical values. First is byte. Byte is the smallest integer type. It is signed 8-bit data type. Sign refers to positive as well as negative value. It is useful when you are working with stream of data from network or file. Means it is useful in file handling as it represents binary data. This is the example of byte variable declaration. Then short data type. It is signed 16-bit data type and probably least used data type. Here is the example. Then integer. It is signed 32-bit data type. Useful to control loops and indexing arrays. Loops are the ones that does some specific task until some condition occurs. An array is a group of same type values. Example. Then long. It is signed 64-bit data type and generally it is useful for those instances where integer is not large enough, such as storing mobile number. Example. Now second part of primitive data type is floating point. These types are used when we require fractional part while working with expressions used in calculations such as square root. There are two types of floating point. First is float and second is double. Let's see float. It represents single precision IEEE 754 floating point. It is 32-bit data type. It is faster than double because of its single precision format. This data type is never used when higher precision is required. It can represent at max 6 to 7 digits in fractional part. Example. Double. It is signed 64-bit data type. It can represent at max 15 digits in fractional part. It is useful when you require more accuracy. Example. Third primitive type is character. Unicode is a computing industry standard designed to consistently and uniquely encode characters used in written languages throughout the world. So to support all the characters for global portability, character is of 16-bit. There are no negative characters. Example, Boolean. It is useful to represent single bit logical value. There are only two possible values, true and false. It is used by conditional expressions. Example, there is a range for each and every data type and it differs according to their width. In addition to range, each and every data type has its default value. All the numerical types has 0 as default value. In character, default value is /u and 40, which is null, and its decimal equivalent is 0. Boolean have false as default value, but the question comes in mind, what that range specify? The range specifies minimum to maximum value that a particular data type variable can contain. Now, formation of that range. Let's understand about byte. Byte has 8 bits, so if you are familiar with binary number, then you know it can represent 0 to 255. If you aren't familiar with it, then the rightmost bit represents 2 raised to 0 and its immediate left represents 2 raised to 1. In that fashion, the leftmost bit has 2 raised to 7. Add all the values of bits which contains 1 in their position and you will get its equivalent decimal number. But numbers can be negative, so data type must represent negative numbers also. Negative number can be represented by 2's complement of its equivalent positive number. First bit is reserved as sign bit. If it is 0, then it indicates positive number. If 1, then negative number. So if we set first bit 0, then we can get positive range from 0 to 127. If we set first bit 1, then we can get negative range from -128 to -1 due to 2's complement of 128 and 1. 2's complement is complement of number for which you want to find 2's complement plus 1. In the next video, I am going to cover variables and other stuff. Until then, this is Vishnu Radhanpura signing off. Thank you for watching. Don't forget to subscribe us. Goodbye.